Hello dear students, I am Jithin Abraham. In today's lecture we are going to learn about latent heat. Okay, so this is a part which is coming from heat chapter. Okay, latent heat is basically what? Now you guys are very well aware that whenever you try to heat an object, the temperature of that object rises. You're very well clear about it. So let me present the same scenario in terms of graph. Whenever you try to heat an object, let me say this axis stands for heat energy and this is for temperature. You try to heat an object, its temperature rises. It's directly proportional. When it reaches let me assume initially it is in solid state. When it reaches its melting point, what happens is you are still heating, but you might have observed that at melting point, when you're trying to heat, it melts, it converts from solid to liquid, but its temperature is not rising. Its temperature remains same. It remains constant. So the melting point is actually a common temperature for solid as well as liquid. You consider a very simple example of water and ice. When you have an ice at negative temperature, negative degree Celsius temperature, you try to heat that ice, the temperature of ice increases. As soon as it reaches 0 degrees Celsius, the ice starts melting, it starts becoming water, but the temperature never rises. The ice melts at 0 degrees Celsius, it converts it into water at 0 degrees Celsius, the water exists at 0 degrees Celsius. After conversion, after changing its state, then only the temperature rises. That means that at that particular melting point, I am continuously supplying heat. That means the x-axis is proceeding, but y-axis is not proceeding. The temperature is not rising. So this amount of heat energy, which is not visible at rise in temperature, which is completely used only for changing its state, is called as latent heat. Latent heat is denoted with the help of symbol L. This latent heat which is used for converting solid to liquid, which is evident at melting point, is called as latent heat of fusion. Again, so here it was solid. Now conversion is happening. Again you try to supply more amount of heat. You'll observe that again the temperature is rising. It rises like this. It reaches a particular upper limit. This upper limit will be called as boiling point. Now at this particular point, again same thing happens. Here we had liquid state. At this boiling point, again same thing happens. This liquid is changing its state from liquid state to gaseous state. It's vaporizing itself. But while vaporizing, the temperature is never rising. Temperature remains constant. So this particular amount of heat, I am supplying some amount of heat, but the temperature is not rising. So this amount of heat is called as, again, latent heat. This latent heat will be called as latent heat of vaporization. Again, after vaporization, you simply supply more amount of heat. You will observe that the temperature is again increasing. That means at gaseous state it again goes on. Then, since latent heat is the amount of heat required to melt an object or maybe vaporize an object, mass plays a critical role. The more mass you have, more amount of heat you will require. That's the reason why we make sure that means the amount of heat you require will be directly proportional to mass. That's where a proportionality constant comes, and that proportionality constant is called as latent heat. That means latent heat is defined as the energy required per unit mass to change the state of any particular object. Therefore, the SI unit is nothing but joule per kg. Thank you.